So now let's take a look, no, yung ating core net ay yung ating control plane and user plane sa 5G. So in any system, like for example LTE and 5G, there is a concept that what we call the SDN, software defined network. So the main concept of the software defined networking is you are separating the control plane to the user plane. So for the ease of architecture and implementation. So imagine we have the core network of 5G, and then you have a G node B, and then there is communication happening between these two. There is a different traffic. So we have the user plane. The user plane is this is where this is the plane where it carries the network user traffic. So if you are downloading data, okay, you are downloading a huge file from a certain server, and it will go inside your 5G core, and then before it goes to your user terminal, it will use the user plane. But before the network allows it to be downloaded, there are control planes, okay, that carries the signaling traffic. Like for example, you are delivering something. You order something from Lazada, okay? So when it enters the security guard in your subdivision, it will not allow immediately, right? So there are control mechanisms. So sa tanongin niya ng guard, saan ka pupunta? Ano yung address? Okay, what is the address? Sino yung tatawagan mo dyan? Sino yung taga-deliveran mo? What is the name of the recipient? And then most of the time, if the guard is suspicious about the authenticity of the delivery, because there's a lot of packages arriving in your house, they will call you, no, for authentication. Okay, so that is also part of the control mechanism. So once the mechanism is complete, satisfied, that's the time that the security guard, will allow the delivery of your products. Same thing also when you are withdrawing money, right, from the bank, especially if you're using a bank book, right? So before you enter the bank, so the security guard will ask you probably what is your purpose of entering the bank. Okay, so if you will deposit or you will withdraw, and then if you're allowed to enter the bank, you will proceed to the teller. And then if you'd like to withdraw some money, like for example, you would like to withdraw 10 pesos from the bank. So the teller will not immediately give you money, right? What she will do is just she will check the authenticity of your account. Okay, check the balance if you still have money, and then if the withdrawal is valid, okay, or acceptable. So if all requirements are complete, that's the purpose of the control plane. And the user plane, if the all the essentials or all the thresholds are been met, or parameters has been met or have been met, that's the time that the user plane will open up, and then the money will come out. Okay, so that's the same with our network. Okay, so that's how the control plane and the user plane are separated. Okay, so if you look at this is a deeper protocol stack, okay, that we are looking at in the 5G protocol stack. So you have these, like for example, the OSI layer stack, okay? So you have the application, presentation, session, transport, network, data, physical. If you map it in the 5G network stack, so you have the application of service, open transport protocol, upper network, lower network, and open wireless architecture. So this is the 5G network stack. And if you separate the user plane protocol and the control plane protocol, maalala nyo to? Si SDAP, PDCP, RLC, MAC, and physical. So that's the importance of knowing those protocol, because we need to understand where are these protocols happening, no, in the layer of the network. So you have the user protocol, and then you have the control protocol. So usually the physical, MAC, RLC, and PDCP are same in the user protocol and the control plane protocol. And there is an added protocol, the SDAP, okay, in the 5G, okay, the service data adaptation protocol, and the NAS for the UE. that is connecting good directly to the core network once you establish your connection. Okay, so this is the 5G protocol stack. So why we are studying this now? Because when 5G will be if 5G will be deployed, and then we will be using the what we call the RU CU DU split. Okay, so what is this RU DU split concept? So remember the basic architecture of a 5G or 4G network. So you have the core network. Okay, you have the core network, you have the baseband unit, and you have the radio unit. Okay, you still remember this? And the baseband unit is connected via backhaul network, and the BBU is connected via front haul network to the RRU. Okay, under the 3GPP approach, technical reference 38.801, so they introduce what we call the network split or the RU-CU-DU split. The BBU functionality, the baseband functionality, is now separated into two. We call it the CU and the DU. Okay, so by splitting these functions across multiple units, so 5G networks can be deployed in more flexible and scalable manner. Remember this one, the cloud optimized architecture. Okay, so where we want to separate some of the components of the 5G network. So para tayong merong Lego system dito. So we are separating first, no, yung ating baseband unit into two, the centralized unit and the distributed unit. And the RU is still the same, no? So the radio unit. Okay, so this is what we call the RU-CU splits. Now, after splitting, no, we are splitting the physical component of the baseband unit. Now it's time for us to split also the protocols. Okay, so remember the protocol previously. This one. Remember that in the BBU, RRC, PDCP, RLC, MAC, and physical are located in the BBU, and RF is in the RRU. Okay. Now, what will happen if the BBU will be separated into two, or will be split into centralized unit and distributed unit? So what will happen if we separate the BBU to the CU-DU? The protocol will also be distributed. Okay. So previously, this one is in one BBU, right? So now we are introducing the functional split options for 5G. So in the CU, there's a possibility that in the CU, you can see the RRC or the PDCP or the high RLC or the low RLC. It depends on how the vendor or the operator wants to have the split. Where do they want to do the split? Okay, so if it's option 2, the PDCP and the RRC protocol will be located in the CU. And the high RLC, high MAC, low MAC, and the high physical will be on the DU. Okay, so you can see also the layer 1 functions, the layer 2 functions, and the layer 3 functions here. And if you look at some details in the diagram, is like this. So the BBU previously is this one. Okay, now separated into two, centralized unit and a distributed unit. And the centralized unit is divided into control plane, and the user plane. And then the DU is now equipped with the RLC, the MAC, and the high physical. Okay, so this is how the disaggregation, meaning we are splitting the component, the hardware component, and also the protocols inside the components. So why is it important? Why do we need to separate this one? Remember, we have a different use cases in 5G. What are those? EMBB, URLLC, MMTC. These applications or use cases require different architecture structure. Okay, especially for like for example in the URLLC, where there is a need for a low latency communication, meaning kinakailangan natin mabilis na response ng network. So how do we do that? If your core network, like if your baseband or the cell site or the baseband unit is located 10 kilometers from you, no, even though sabihin natin the speed of light, there's still a delay. No, that is noticeable. So in order for us to do that, we need to move some part of the network near to the users to increase or to reduce further the latency. Okay. So that's why we are disaggregating the network. No, so we have a different use cases, use cases and applications needed. So in this case, if we separate this a component, there will be another interface. No, so previously the connection between the RU and the DU, we call it the front hole, and the CU and the baseband and the core network, we call it the back hole. Now, since the baseband is separated into two, we have DU, distributed unit, and the centralized unit. We call it the mid hole. Okay, mid hole. So this is the connection between the DU and the CU. And you can see here, these are the latency requirements for each interconnection, the maximum latency and the maximum distance that can be covered. You can see that the CU and the DU can be located at the 20 to 40 kilometers apart, while the DU and the RU can be from 1 to 20 kilometers. So it's possible that your distributed unit is located in one building and your remote unit can be located on the other building. So that's possible, no? As long as you satisfy this coverage requirement and latency requirement based on your applications. Okay. So, so why do we need to have a split, no? So these are the three factors for a RAN splitting. So there's a need to support specific quality of service per offered services. Just like I mentioned, your low latency for URLLC, high throughput for EMBB, and real and non-real-time applications. There's also a specific need for specific user density and load demand per given geographical area. There are areas that a lot of users, and there are areas that are very a few users. No, so there is a specific support needed on this type of applications, and available transport networks with different performance level. So transmission network is expensive. No, so we need to optimize how we will use our transport network to further address some applications. So this is a typical example from parallel wireless. So you can see the different splits. No, for Open RAN, the split that is recommended is the split 7. Okay, the split 7. And for applications like 2G and 3G, if you will do the splitting, it's recommended to have the split 8. The split 8. So the split 8 is a simplified, the most simple, the simplest split that we can implement for 2G and 3G, because the services for 2G and 3G are not so complicated like the services in 4G and 5G, where we can embed the circuits in the radio part. Okay, so if the functionalities are simple only, you can have simple circuit or microchips inside this RRU. Okay, RF. So that's why in the 4G and 5G, split 7 is one of the recommended split type. Okay. All right. So that's our 5G discussion for today. So it's a combination of simple concept going to some deeper concept on 5G.